Hi, we're going to talk about periodic functions and periods now. To start, let's talk about what is a periodic function. So a periodic function is a function that returns to the same values regularly. So what that really means is when we look at a function, it's going to have some sort of cyclical pattern. It'll have the same values over and over and over again as we go throughout time. One of the most common ones that we see is the sine of x, and we're going to talk more about this one in a few minutes. I just wanted to show you this one right now because you can clearly see that we've got this value here at the x-axis. Then it has this peak right here. Then it goes back to the x-axis and down to this peak and up to the x-axis and back to that first peak and so on. So this has some periodic trends to it. In some more complicated functions, you might not necessarily see the periodicity within them at first, but you have to look a little bit closer to see where there are some similarities. Well, if I look at this function, it looks like there is this weird going up and down and back and up, and I see the same thing right here. So clearly there's some sort of thing going on. And if we actually looked from the very beginning here, this timestamp of 0, and then we ended it at right here. We could follow this line and see that it is the exact same as this line. And as long as that is true for the entirety here, if it keeps going up and down, all the same, including all of this, all the way to this point, then it is a periodic function. This one's a little bit hard to see. But this one is a little bit easier to see. If we looked at this one, this is actually something that you'll see if you ever go into engineering, like electrical engineering, the amplitude of waves, of electricity, of current, that is, this is an example of that. So there's these square curves. And so it looks like we've got this one single value here, and then all of a sudden it jumps down to this value, and then it jumps back up to this value, and then down. And so there's the same periodicity to it. It's going to be going up and down according to this certain period. And a period then is how long does it take before it goes back to where it started. So we started here at the very beginning at this top. We follow this. We go down. Where do we get back up to normal? Right here. And so our period is the length of time between here and here. And we can actually put that into better words here. So a period, we can put that into better words. It is kind of like your time it takes for a function to return to its initial position, or you could think about it as value. You have to be careful though, because over here on this one, it looks like we return to the same value here that we started with, which is 0 here, and we return to it again here and here, but it's not necessarily a new period. It doesn't exactly mimic its own behavior until we get all the way out here. That is the beginning of the next period. Okay, let's talk about this one then. This is one of the most famous periods out there, the periodic function. One of the most famous things is the sine function, and then after that is probably the cosine function. So these are waves, and they describe a lot of natural things like the changing in temperatures per day, or the changing of temperatures throughout the year, or seasons. Anything that has a cycle to it can typically be modeled by a sine function or a cosine function, and we're going to learn more about these in the next couple weeks in this unit. So we're going to talk about what the period is in this one. Now, if you've ever looked at your calculator and seen rad versus degree, the rad is called a radian. That's the full word for that. And that is really important because it's kind of like the timekeeper for a periodic function. And what a radian is it actually, instead of talking about the length of a period in terms of a degree, where a degree goes from 0 degrees all the way up to 360 degrees, a radian works within terms of pi. And so it's going to have a starting point of 0 pi, or in other words, just 0. Whoops. In other words, just 0, because 0 times anything is just 0. And then 360 in terms of pi is actually 2 pi. So it takes 2 full pi's to get all the way up to a 360, one full rotation around. Now, what happens with a single pi? 1 pi is actually equal to 180 degrees. So we can put that in here, in the middle here. That's going to correspond to 180 degrees. And you can continue to do this. If you wanted to find out what 90 degrees is, well, what is 180 divided by 2? It's 90, so we take the corresponding value over here. This was 180 degrees equivalent, pi. So if we wanted to find out what 90 degrees was, we would take that, divide it by 2, and we would get pi over 2. So this is important, but this is not the main focus of this video. So I'm actually going to erase this in just a moment. But you can see that there is this corresponding value between radians and degrees. They both work around the idea of a circle, of a cyclical pattern. Okay, now that we've got that, we can focus on what the actual what the actual period of this function is. Now, let's look at just the positives. Let's assume that this is our starting position. So it looks like it will follow this curve up, it'll go back down, and then it goes back up. And at this point right here, this is the beginning of our new period. And so whatever the time length is between this 0 and whatever this value is, 6 point something, maybe 6.2-ish, that is going to be our period. Now, it helps actually that we put it into degrees. Now, I'm going to go down to this next function right below. It is still this exact same function. This is still sine of x. However, instead of spacing these out in terms of 1, 2, 3, 4, and so on, I have actually spaced this out in terms of pi, 2 pi, 3 pi. And now you can see that the function is exactly lined up. Now what I mean by that is that here's 0, and then it goes up. Here's the peak, and it is exactly on one of these intersecting lines. Goes back down, touches the x-axis exactly at pi. Goes down, and its lower peak is exactly halfway between pi and 2 pi, and then finally it goes back up into 2 pi. So this is what I meant before by radians having an entire cycle in 2 pi lengths. So the period of the sine of x function is 2 pi. The period of sine of x is 2 pi. Now let's look at the intermediate values here. What should this value be here? Well, it's exactly halfway between 0 and pi, so that would be pi over 2. Now what would this value be? It's exactly halfway between pi and 2 pi, Think for a moment, what should that be in a fraction form? And if you said 3 over 2 pi or 1.5 pi, that would be good. Okay, that is a quick intro into determining the length of a period for a function that is periodic. Make sure that you look exactly for where it begins a new period before you call it quits on it. You cannot say that this is a new period here. You have to wait until it goes all the way to the end.